Everyone. So remaining a large sample, already we in the previous class we have discussed about the two sample mean and one sample mean, and based on the test of hypothesis we are going to discuss the remaining topic. So once again I will my name is Rekha, Assistant Professor, Department of Mathematics. Today I am going to discuss the topic test of hypothesis, remaining problems in the discrete mathematics with probability and hypothesis testing. So previous class we have discussed the problem based on the two sample mean and then one sample mean. Here are the related problems is given. So based on that, so it is in two machine learning problem models are given, that is accuracy for the model X and model Y. For example, if we take the two model, for example Vivo and Samsung, like that we have taken the two sample from the Vivo and and similar some sample from the Samsung. So let us consider the model X as 1024 samples with the mean accuracy of 92.3 and S equal to 3.8, and whereas for model Y it is 900 sample and with the mean accuracy of 91.5 with the S equal to 4.1, and here the alpha is 1% significant and the given value should be treated like this: X value and Y value with the sample size on mean accuracy 92.3 and 91.5 with the standard deviation as 3.8 and 4.1. So for this cases, all the problems it is a large sample case. If n1 n2 will be greater than 0, we have to apply the large sample, and there will be a two sample mean is given, or we can apply the two sample mean concept, that is x1 minus x2 by root of s1 square by n1 plus s2 square by n2. This is nothing but a test statistic using the z. This comes under the normal distribution, and we have to apply in the 92.3 minus 91.5 root of 6.8 whole square plus 1024 plus 4.1 square, right? So if you simplify this value, you will get 0.8 by 0.188, you will get 4.42. So it is an 1% level, means the Z value is nothing but 2.33. The decision we can take that 4.42 will be greater than 2.23. So we reject the null hypothesis and we accept the alternate hypothesis, and we can conclude that model X has a significantly higher mean validation compared to the model Y. So like that we have to conclude the two mean. Next we can go to the next problem. And e-commerce company runs a promotion in a two region, where a region is 2500 orders and an average order of 78.40 with the sigma 22, and they have an average order of 81.2 and with the sigma 23. So similar problem we have done the more problems based on the two mean. So here also east is nothing but n equal to 2500 and the west is nothing but 2200. Here mean is 78.40 and another one is 81.20. Sigma is nothing but 22.23. If the two data is given, means we have to go with the two sample, that is xb minus x1 minus x2, that is we can by root of sigma 1 square by n plus sigma 2 square by n2. Here you can name the variable for your own, either otherwise you can adapt with the formula. So that is nothing but 78.40 minus 81.20 by root of 22 square by 2500, 23 square by 2200. So I will get z equal to 4.42 minus modulus of. So this minus value is nothing but modulus value, so you can take it as a positive. Here alpha is an 1% significant level, so you can write it as an 2.576. It is a two-tailed test means. So this data you can keep on the values, otherwise you can see from the normal distribution, otherwise you can remember the 1%, 2% and 3% level. So you can conclude that there is a strong evidence between the average order value significantly become the region east and the region west. So these problems can be done using the two sample mean and whereas from the single sample mean. So based on the two sample mean and the single sample mean, we have the two formulas. So some cases if the sigma is given, means we have to apply the standard deviation, otherwise sigma not given means we have to go with the pooled variance formula. So that we have to adopt. So I think you will understand the single mean as well as the two mean formula. So in the all the units are covered with the large sample and as well as the single mean and small mean. So thank you for listening the video.